Good morning and welcome back. Today we are going to continue with parallelograms, specifically talking about three special types of parallelograms. So parallelograms we've already talked about so far, and we know with parallelograms we are going to have a situation where opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, meaning add up to 180. And then finally, the diagonals will bisect. And today, all five of those rules will still be true. However, with special parallelograms, there are a few other types or things that are true as well. Okay, so the first thing we want to talk about is a rectangle, and it says this is a parallelogram with four right angles. I'm guessing you guys are familiar with this. All of these angles are going to be right angles, meaning they're 90 degrees, and we don't have markings on here, but you already know that opposite sides of a rectangle are congruent. Also, you know that if they're all 90, that would mean opposite angles would be congruent. Consecutive angles, 90 plus 90 is 180. The diagonals are not in here, but they would bisect. Okay, so that's a rectangle. The second type is a rhombus. Now, a rhombus is going to be a parallelogram with four congruent sides. So each of these sides is the same length. If one was 5 inches, then the others are all 5 inches. Okay, so opposite sides are still congruent. There are no markings, but opposite angles also would be, consecutive angles would be supplementary, diagonals would still bisect. All of those are still true. Then the final one, a square. You're familiar with a square, but you might not realize it combines both of these rules, a rectangle and a rhombus. So a square is when we have a parallelogram with four congruent sides and four right angles. So you can see the sides are marked as the same, and then the four angles are all 90 degrees. Now, these are our three different special types of parallelograms. And finally, then, the diagonals of these parallelograms have a few special rules as well. So if we look here, let's see. Not sure why those marks are showing up there. But if we look here, the diagonals of a rectangle. Anytime we have a rectangle, the diagonals not only bisect, that is true about all parallelograms, but the diagonals would also be congruent, meaning from A to C is the same as from B to D. Or you could say CA is the same as DB. Now there's no mark here, but if I would put a mark here and say call it M, AM, BM, DM, and CM would all be congruent. Okay, that is the case because they bisect each other, and if they are the same, that means if they're both bisected, it'll be the same distance on each of the four parts. Okay. Now our next one. So if you're taking notes by hand, at least write this rule, right? The diagonals of a parallelogram or of a rectangle are congruent. Okay, now if it's a rhombus, they don't have to be congruent. If we look here at this rhombus, BD and AC will not necessarily be the same length. However, the diagonals will be perpendicular. And if they're perpendicular, that means that right angles are formed. So each of these would be a 90-degree angle. That will always be the case if it's a rhombus. And much like up above, the square kind of puts these two rules together. If we have a square, the diagonals will not only be congruent, so AC and BD are the same length, as you can see marked right here, but also they will be perpendicular, meaning AC and BD are perpendicular. They form 90-degree angles here, and we are done. So those are our three rules. Remember, a rectangle is a parallelogram with four right angles. A rhombus is a parallelogram with four congruent sides. A square is a parallelogram with both of those, four congruent sides and four congruent angles that are right angles. The rectangle, meanwhile, has diagonals that are congruent. The rhombus has diagonals that are perpendicular, and the square has diagonals that are both congruent and perpendicular. So if we look here, it says ABCD is a parallelogram. So we have two different examples of it, A and B. Determine whether there is enough information to conclude that ABCD is a rhombus. Now on this first example here, if there is a right angle here, we can look, and these are a linear pair, so we know that this would also be a right angle. Then there's a linear pair, there's a linear pair. All four of those are right angles, meaning that those diagonals BD and AC are going to be perpendicular, which therefore tells us yes, this is a rhombus. Not only is it a parallelogram, it is a rhombus, which means I could go ahead, because I knew it was a parallelogram and it had that right angle, I know that each of these sides is the same. Now, on letter B, it does appear that these are right angles, but without proof, we have no way to know that for sure. Without measuring it, we cannot make this conclusion. No, we don't have quite enough information that it's a rhombus. Now, if there was a mark here and here, that would work, or if one of those had a right angle in them. But without that, no, we don't have enough information. All right. And the next one here says, in the given rhombus, the measure of angle XYZ is 5b minus 10. Now, XYZ. X is here, Y is there, Z is here. So XYZ, the angle is right here that we are trying to find. Because it says use the rhombus WXYZ to find that WZ, or to find WZ and the measure of XYZ. So the arc I put here, that's what we're trying to find. So there's two things we're finding. One is related to angles, one is related to sides. One will use the letter A as a variable, one will use the letter B. Let's start with A here, and that's on the sides. So WZ. First thing we can know is because it tells us this is a rhombus, I know that each of these sides is the same. They are all congruent, which means I can go ahead and set up 9a minus 11 is equal to 6a plus 7. I know that is true because it's a rhombus. And on rhombuses, the opposite sides are always the same. Sorry, not just opposite sides, all the sides are the same. So these two sides would be the same. At this point now, just solve it using algebra. Then we'll add that 11 over. And from here, divide by 3, divide by 3. A will equal 6. We're not done though. It asks for WZ. So we need to plug that in. Now WZ is right here, 9a minus 11. So we can plug it in for that A. The thing is, if you prefer, you could actually plug it in over here because hopefully you remember these are the same. So I don't care where you plug it in. If I plug it in there, 9 times 6, 54, minus 11, that'll be 43. And our label here, millimeters. So that is our answer for what WZ is. Okay, if you wanted to double check, 6 times 6 is 36 plus 7 is 43. That's the same, so that's good. We did it right. Okay, now I'm going to switch to blue to solve for the second one. Our end goal is to find the measure of XYZ. We know that the measure of angle XYZ is right here, 5b minus 10. So if we can figure out what b is, we can plug it in right there and multiply it and then subtract 10 and we'll have our answer. Here's the thing. We don't know what b is yet, but we know this is a rhombus, which means that each of these is a right angle. The diagonals are perpendicular, so 5b plus 20 must equal to 90. Now, if that is the case, subtract 20, 5b will equal 70, divide by 5, and b will equal 14. Now, if you're having trouble keeping up with the math, you can use a calculator. That's totally fine. I'm doing some of this in my head, but if you are not as good at mental math, use a calculator. That's great. We just need to be able to get the answer. So we'll plug that 14 in. 5 times 14 gets us to 70. Minus 10, our final answer, then will be 60. And since it's an angle, 60 degrees. And that's our answer here for angle XYZ. All right. Our next one. Example 3 has DEFG. This is a rectangle. So if it's a rectangle, let's think about what that tells us. We know rectangles are parallelograms with all four angles as right angles, and they also have congruent diagonals. So here DF is 5x plus 15, GE is 8x minus 18. We need to solve for x. We just mentioned diagonals are congruent, so 5x plus 15 must equal 8x minus 18. We will subtract 5x. Now it's just an algebra problem. At this point, we can add 18. Divide by 3. X will equal 11. And we are done. Now, if it asked us to solve, we would have to plug in. It does not ask us, so we don't need to. But it asks for what DF or GE is. We could plug them in and solve. All right, example 4. QRST is a square. A square, remember, is a parallelogram in which the diagonals are congruent, the diagonals are perpendicular, the angles are going to be right angles, and the sides are all going to be the same. Now QS is 7n minus 12, RT, the other diagonal is 3n plus 8. We'll actually solve this one exactly the same as we did the last one. Even though it's a square, the same rules apply. If anything is true about a rectangle, it is also true about a square, because the square will have all of those features of both a rectangle and a rhombus. And we'll divide, and we'll get n to equal 5. All right, one final problem I want us to do together. Then after this, I'll show you one of the answers to the homework to reward you kind of for sticking around for the whole video. So I'm sure some of your classmates have tuned out. So ABCD is a rhombus. Remember, rhombuses we know are going to have all sides the same, and the diagonals will be perpendicular. So it says ABCD is a rhombus. Find the measure of angle ABC. So ABC is right up here, and we know that that is equal to 10n plus 5. Now, if I know what n is, I can plug it in. However, I don't know what n is yet, but here's a right angle. 7n plus 13 must equal 90, because remember, diagonals are perpendicular. So we'll subtract 13. 7n equals 77. Divide by 7. N equals 11. Okay, all we have to do now, plug that in. 10 times 11 would be 110, plus 5 gives us 115 degrees. Now, as you can tell, this picture is not drawn accurately because this angle is acute. It would be less than 90. So our picture is off a little, but we have to trust based on the rating. Okay, so in reality, I should have made that BAD. It would have made more sense. But 150 degrees is our answer. Now, the final thing I'm going to do in this video is show you guys the answer to question 2. So today's assignment, go to Delta Math. There are 5 questions. Keep in mind, these questions are a little different in that I uploaded them. They're teacher-created problems, which means there aren't an infinite amount of answers. Or questions. You can't try again and again and keep missing. You have 5 questions. You get 3 tries on each. So if you miss the first 2, maybe pause, ask a classmate, send me an email, ask for help. Okay, so QRST here. This is a rhombus. This is find ST. So our end goal is to figure out what this side is. Keep in mind, if it's a rhombus, all the sides are the same. So if I can figure out what the sides are, I will know my answer. Now, 4t minus 11 and 2t plus 13, those are 2 sides right now. We know those will be equal to each other. So 4t minus 11 equals 2t plus 13. Subtract that, and you will give me 1 second to pull up. All right, so as I pull up this canvas here, sorry, I can just use that to solve. So we said we know that 4t minus 11 has to equal 2t plus 13. So we can subtract 2t. Then we'll We'll add 11. Then we have to divide by 2. T will equal 12. Now keep in mind, that's not the question. The question is find ST. To find ST, we need to plug it in to one of these sides. Now, since it's a rhombus, all 4 sides will be the same. So either 2t plus 13 or 4t minus 11. It is your choice which one looks easier. I'll plug it into 2t plus 13 to stay positive. But if I plug that in up here, so 2 times 12 plus 13. 2 times 12 is 24. Plus 13 will give us an answer of 37. And all we have to do then is find ST. 37, submit, hit yes, and we're done. So there are 5 of those, but that's the answer to number 2. If you guys have questions, reach out. Let me know. Hopefully I'll be back tomorrow, but we'll see. And I'll talk to you later. Have a great day.